This lesson's about electrochemical cells and terminal potential difference. Here are your objectives. An electrochemical cell, what we in everyday life might call a battery, uses chemical reactions to separate charges. And in doing so, it takes the chemical potential energy that's stored in the reactants inside the cell, and it changes them to electric potential energy in the separation of positive and negative charges, which want to get back together. We're used to drawing cells now like this, with a positive terminal and a negative terminal. And what you might be used to thinking of as a battery in everyday life, let's say a AA battery, is actually a cell, and here is the positive terminal and here's the negative terminal. Now we know that if we take the two terminals of a cell and we connect them by an external circuit, so here's a circuit going through a bulb like that, then the separated charges will flow through the circuit. If we're talking about conventional current, they'll flow in that way. And in doing so, that electric potential energy will be transformed into other forms of energy. In the case of a light bulb, into light energy and heat energy; if it's a loudspeaker, into sound energy; if it's an electric motor, into kinetic energy. So the goal of connecting the cell to a circuit is to take that electric potential energy that's been stored in the separated charges and transform that into other forms of energy. A bit more terminology to consider as well. A primary cell is a non-rechargeable cell, whereas a secondary cell is a rechargeable cell. And secondary cells can be recharged by using another source to force current backwards through it in the reverse direction. So connecting two cells, for example, like this, where the positive terminals are facing each other, would allow one to recharge the other. So let's say this was a 10-volt cell and this was a 3-volt cell. The 10-volt cell here would be recharging the 3-volt cell. A battery is made of several cells linked together in series or in parallel. So this is a diagram of a battery. And what we often call batteries in everyday life are actually cells. Lastly, the terminal potential difference is the potential difference that we would measure from one end of the cell to the other, from one terminal to the other. So there's our drawing, or here's our schematic. In both cases, I've got the positive terminal on the right. And if I were to take a voltmeter and connect it to the two terminals, I'd be reading the terminal potential difference. And even if I connect this cell into a circuit, as long as I'm connecting my voltmeter to its terminals, I'm still measuring the terminal potential difference. Now, as we'll see in the next lesson, whether it's connected into a circuit or not actually is going to affect the reading I'm going to get for the terminal potential difference because of resistance within the cell itself. We'll explore that in the next lesson. Now, the terminal potential difference of a cell varies over time as it discharges. So if this is the terminal potential difference on the y-axis in volts, and this is time, at the start of the life of a cell, it actually starts above its rated potential difference, and then it declines rapidly and then stays at a plateau for most of its life until it is just about ready to completely discharge, and then it drops off rapidly. So it starts above its rated potential difference, spends most of its life at about its rated potential difference, and then drops off rapidly as it discharges. So that's an introduction to some terminology around electrochemical cells.